Okay, let's take a look at some in and out tables today. So we're going to be starting our unit on functions, and we're going to be taking a look at some different types of patterns. So today we're going to just practice some in and out functions just to get our head wrapped around different sorts of patterns. Um, and we're going to use some substitution, look for some rules, and we're really looking at adding and subtracting, multiplying and dividing. So let's take a look at these first two um, function tables. So a function table is such that something x creates something y. So the in is my x value, the out is my y value, the y is the same thing as the answer, okay? So we're going to start at x and go to y. So the rule says I'm adding 5. So what I'm really doing is taking 6 plus 5, that's 11, 8 plus 5, that's 13, 13 plus 5, that is 18, and plus 5 here is going to give me 19. Now this one, I don't have the rule, and I also have a blank. So remember, I'm going from x to y this time. I'm not going this way. Okay, I'm not going down. I'm going left to right, trying to figure out how I go from 69 to 73. So 73 minus 69, that's 4. Well, let's see if that holds. 75 minus 71, so I'm looking right here. That is also 4. To go from 71 to 75, I know that's adding 4. So I'm adding 4 as I go all the way. So then 63 plus 4 is going to give me 67. So my rule is plus 4. Okay, so let's take a look at this scenario. So we're talking about our input in dollars and our output in quarters. So like when you go to the change machine to like wash your car, and it takes quarters, if you put in a dollar bill, if I put in $1, that would give me 4 quarters. So $1 gives me 4 quarters. So it says if I have $6, I get 24 quarters. And if I put in $5, I'm going to get 20 quarters. And $4 gives me 16 quarters. $3 gives me 12 quarters. Well, what is the relationship here? How do I go from 3 to 12, 4 to 16, 5 to 20, 6 to 24. Well, I'm definitely not adding something because 12 minus 3 is 9. 16 minus 4 is 12. I do not see a constant pattern there. So it definitely is not an addition pattern. And I know that I'm increasing because the numbers are getting bigger. So I must be multiplying. Okay, I must be multiplying. So let's see if we can figure out our multiplication. So I'm going to go ahead and pull up my Desmos calculator here. Just give me just a second to pull my screen across. And let's pull up our Desmos calculator. And let's do some division and see what we have. So let's take 24 divided by 6. That gives me 4. Well, let's take 20 divided by 5. That also gives me 4. And 16 divided by 4 gives me 4. So I see that that all of these are 4. So if I am thinking about what I'm doing from 6 to 24, that's times 4. 5 times 4 is 20. 4 times 4 is 16. 3 times 4 is 12. Okay, so that's my rule. I'm multiplying by 4. Well, if I put in $20, how many quarters am I going to have? Well, it's the same thing. So I start with 20. I'm going to multiply by 4. 20 times 4 is 80. So I would have 80 quarters. 80 quarters. Okay, we have to make use of our calculator here, and it's giving us a rule that says division. Okay, it says division. So that means I'm dividing by 9. So I'm going to take 414, I'm going to divide that by 9. I should come up with an output that is smaller. So let's start with 414, 414 divided by 9. That gives me 46. So this is 46. Let's do 495. 495 divided by 9 gives me 55. And 693 divided by 9 is 77. And 720 divided by 9 is going to give me 80. All right, now let's try to figure out what's going on in this next one. So I know that I'm going from a small to a big. So that means my rule is going to be multiply. But if my rule is multiply, because it's a whole lot bigger number, then to figure out the pattern or the rule, I need to do the opposite. So I'm going to actually divide. I'm going to take 770 divided by 70 and see what I get. So 770 divided by 70 says it's 11. Let's try this one. 704 divided by 64. 704 divided by 64 is also 11. And let's check the last one. 539 divided by 49 gives me 11. So I see that my rule and the number I'm dealing with is 11. So it's really multiply by 11 when I go this direction. If I'm going the opposite direction, it's division. So 45 times 11 is going to give me 495. So this answer is 495. Okay, let's take a look at this table. And let's see if we can read the table to answer some questions. So Keith's age is on top, 4, 9, 17, 22, 26, 29. And Jason, his age is below. So these two were born on the exact day, but not in the same year, and their ages are shown in the table below. So when Keith was 4, Jason was 8. When Keith was 9, Jason's age was 13. So what is the pattern from my X to my Y? Well, it looks to me like I'm adding 4. Okay, so if Keith was 9, how old was Jason? Well, Jason is 13. When Jason was 30, how old would Keith be? Well, Jason, 30. So Keith is the opposite, so he would be 26. So how much older is Jason than Keith? Well, he's going to be 4 years older. 4 years older. So which best explains the rule for this table? Add 4 to Keith's age to find Jason's age. Subtract 4 from Keith's age to find Jason's age. Subtract 5 or add from Jason's age. Well, we know it's not that one because I know there's a 4 involved. And add 4 to Jason's age to find Keith's age. Well, if we're going to be, we always start with the small number, our X value, to determine our rule. So to go from Keith to Jason, I was adding 4. So the answer would be A. Okay, so let's take a look at this function table. So the first thing we need to see is that this is called f of x. Okay, we read this f of x, and it's just fancy y equals. Okay, it's just fancy y equals. It's not any different than what y equals really is. It's really the same thing. So we are going to substitute in for our x value to come up with our table. Okay, so our equation is x minus 4, and I'm going to substitute in for x, and I'm going to start with the negative 6. So I'm going to go ahead and use my calculator over here, and I'm going to use parentheses just to keep my signs straight. So negative 6 and minus 4, that's going to give me a negative 10. Now I'm going to do the same thing. I'm going to come up here, and I'm going to change that negative 6. I'm going to backspace. I'm going to change that to a 9. Well, 9 minus 4 is 5. If I do the same thing, substitute in a 0, 0 minus 4, that's negative 4. Well, if I put in a negative 4, that gives me a negative 8 and a negative 7. That gives me, oops, I have too many negatives there. That gives me a negative 11. Okay, we're going to do the same thing on this next problem to come up with my function values. Okay, so I have f of x equals negative 16x plus 4, and we need to come up with the function values. So remember when we do division, We have a fraction. That's really just division. So 1 divided by 6. So I've got negative 1 divided by 6. I'm going to move over. I'm going to throw my parenthesis in here. And again, I'm substituting. So I'm going to substitute in a 5 to start with. And I got too many parentheses there. Let's get rid of a couple of these extra ones. I just need the 5. I'm going to come outside and I'm going to add 4. So negative 16x plus 4 gives me 3.16666. So let's just round that to 3.2. Because we can't graph 0.16666 anyway, we're going to round to the tenths. Let's change that 5 to a negative 5. And you'll see that my answer changed to 4.8. And if I change that negative 5 to a negative 4, that gives me 4.7. And if I change it to a negative 9, I have 5.5. And what about the last one? Make it an 8. That gives me a 5.3. So technology is definitely very helpful when we're trying to fill in a table of function values. And remember, function values, f of x or g of x or h of y, whatever it might be, that is really just fancy y equals. It's just another form of writing an equation. Okay, so let's take a look at this function graph where we're trying to evaluate the value of a function from a graph, okay? From a graph. So I'm going to start with f of 2. F of 2. So here's what I have to remember. I have to remember that this is really f of x. So what it's saying is x equals 2, okay? Saying x equals 2. So if I look at my graph, here's x equals 2 right here. Well, what's the y value at that point? It's 0 because it didn't move. It's on that actual ordered pair is 2, 0. So the y value would be 0. So f of 1, well, here's the 1 on the x. There's where the graph hits. What's that value? Yeah, it's negative 1. This ordered pair is 1, negative 1. And I'm looking for the y value. That's what I'm looking for, is what is the y value? Now, the opposite is I give you the y and you're looking for the x. Okay, I give you the y, you're looking for the x. So if I give you f of x equals 0.5, which it means I'm at 0.5 here, what's the x value? Well, it looks like it's about 0.52. And what is f of x is 2.5? Well, 2.5 is here. What's the x value at that point? It's 0. It's 0. So again, it's how we're reading our graph, okay? Sometimes we're looking for the x value, sometimes we're looking for the y value. This is the x value. These guys are the y values. So we're just trying to analyze what number matches the graph. So if I said find f of 5, that's the x value. You're going to go to x, you're going to come up, figure out where it's crossing. Where is it touching? Well, it's crossing at about 2.5. So that is the value of the y at 2.5. Okay, let's see what you can do today. Should be a pretty easy day for homework. And tomorrow we're going to move into evaluating functions.